Hey guys, Mr. Milton here. Today we're looking at similarity in right triangles again. Okay, at the end of this video, you should be able to simplify right triangle similarity by using and understanding the new theorems. Okay, so let's recall geometric mean is going to be a big part of today's lesson. Geometric mean is basically the number, the average of these two that after you multiply them. So we have 8 and 32, and so the geometric mean between 8 and 32. Set this up. It's the number that makes this true. And so 8 times 32 gives us 256. So x squared equals 256. Take the square root. That's 16. No, it's bigger than that. 24. It is 16. Huh. 16. All right, so x is plus or minus 16. Okay. Now, as we do this with 15 and 20, geometric mean is the number that makes this ratio true. Okay, I'll just use y not to confuse myself. So 15 times 20 gives us 300. So y squared equals 300. Take the square root of that. No, that's 100 times 3. That's 10, a pair of 10s. All right, and so we have 10 that goes out, 3 that stays in, and remember there is a positive and a negative there. Remember that we only wouldn't say plus or minus if we're actually finding a length, right? Because then that length would have negative lengths. All right. So we learned this yesterday. The altitude of a right triangle divides the triangle into two similar triangles. Similar. And the altitude is that line from the right angle perpendicular to the hypotenuse. Okay. Both of which are similar to the original, and this was the redrawing section of the notes from yesterday. That's what we talked about. And so when we look at this, we say ABC is similar to triangle. So we look at this ADB. Okay, and also triangle BDC. Okay, and so this is what we did previously when we took the large triangle. Right, we have this right angle, so ABC. As we set up the next triangle, we kind of give them all there. In our smaller triangle, D was our right angle. Right, we still had A here, and this is B. And then in that medium triangle, a little bit bigger than the small one, but smaller than the original, our right angle was D still. Okay, we had our short side B. Yeah, cool. All right, and so we would notice that, hey, these triangles are all similar to each other by angle similarity, right? Our short and our original triangle have angle A and the right angle the same. Our large and our original and our medium triangle has angle C and the right angle similar to each other. Okay, so these are all similar by angle similarity, and then these two similar by the transitive property. Okay, so here are corollaries, and remember corollaries are kind of like logical conclusions. Like if this is true, the corollary means that this is also true. Okay, and so it says in a right triangle, referring to the original triangle, the length of the altitude to the hypotenuse is the geometric mean of the lengths of the segments of the hypotenuse. Okay, and so what this means is the altitude to the hypotenuse, this line that we saw in all of our triangles that separated it into similar triangles, this is the geometric mean between these lengths. Okay, and like I said, geometric mean is going to be important. But now, as we set this up, we can say, okay, if x, this altitude, not the variable, so don't get stuck on the variable, but this altitude, this line, in this case, x, is the geometric mean between the two sides of the hypotenuse, 4 and 9. And so we can cross multiply, x squared equals 36. Take the square root, we find that x must be 6. Okay. Corollary number 2. It says in a right triangle, again referring to the original triangle, the altitude to the hypotenuse separates the hypotenuse so that the length of each leg of the original triangle is the geometric mean of the length of the adjacent hypotenuse segment and the whole hypotenuse. Okay, and so what that means here is that this leg x is the geometric mean between the side of the hypotenuse is closest to, in this case you'll see that it's 8, and the entire hypotenuse. And that entire hypotenuse is 18. Okay, so the leg of the original triangle, which in this case is x, is the geometric mean, and I like filling that in first because it's most of the, it's 2 of the 4 spaces between the side it's closest to, in this case it's 18, and the entire hypotenuse. So this side is closest to is 8, right where the split is, and the entire hypotenuse is 18. So as we cross multiply, that gives us 144. So x squared equals 144. Take the square root, x is 12. Okay, we can do that same thing for y. Y should be the geometric mean. Y should be the geometric mean between the side is closest to, 10, and the entire hypotenuse, which is still 18. So y is the geometric mean between the side is closest to, 10, and the entire thing, 18. So 10 times 18 gives us 180. Y squared, that should be like 36 times 5, and that's 6. So we have 6 radical 5. They're giving us these values, and they want us to find x and y. Okay, so now a couple things that you should notice with these corollaries is that when we first got this, we were told that this is the geometric mean between these lengths, right? But the first time it was a variable. It might be a variable and it might not be. Okay, in this case we have 6, but the property stays the same. This altitude is the geometric mean between these two sides. Okay, and so I have 6 as the geometric mean between x and 2. Okay, and so I can cross multiply. 2x equals 36. Divide by 2, x is 18. Okay, so I know that x is 18. Okay, now that helps me out in 2 ways. Now, I know we talked about corollary 2, and you can use corollary 2 because I think it's nice. It's quick. But the other thing that I want to bring to your attention is this is a right triangle here. We can use the Pythagorean theorem to find y, right? Y is the hypotenuse. We could say 18 squared plus 6 squared should equal y squared. Okay, and if we do that, I don't know what 18 squared is off the top of my head. 324 plus 36, 360. We find that y squared is 360. Square root of that, 6 radical 10. All right, that's what we found using Pythagorean's theorem. Let's use our corollary. And our corollary said that the leg of this triangle should be the geometric mean between the side is closest to, and the side is closest to is 18, we just found that out, and the entire hypotenuse, and that's 18 plus 2, 20. So 18 times 20, 18 times 20 gives us 360. So you'll see that we ran into the same thing. We found that y squared It's going to be 360. Whether we use Pythagorean's theorem or the corollary, we come to the point where y must be 6 radical 10. Yeah. Okay, so use that Pythagorean theorem as well. A helpful tool to have, especially for this section. We found it there. What was it? 18 and 6 radical 10. Put it there just because my spaces must have messed up in copying that over. Okay. Example 2 says find the values of the variables using the appropriate shortcuts. Okay, and so now they're asking us to find x, y, and z. Okay, here's the nice part about the corollaries. Okay, I can find x without finding y. I can find z without finding y. Okay, that was the nice part about the corollaries. Sometimes you'll see problems where they don't give you y, and they just say, hey, find x, find z. Okay, and if they don't give you y, if you're trying to use Pythagorean's theorem, what you're going to be forced to do is take a little bit more time to find another variable that don't necessarily get credit for knowing. Okay, so, but at the same time, this is the easiest, I think, corollary to remember, that this line is the geometric mean between these two portions of the hypotenuse. Okay, so I would probably recommend that, especially if you're given the directions to find it, that you find that first. Okay, split that side 4 and 5. Cross multiply, 20 equals y squared. Take the square root, and that's 4 and 5. 2 and 2. So we have 2 radical 5. That's y. Okay, and so we find y to be 2 radical 5. Again, you can use the Pythagorean theorem to find x if you'd like, and y if you'd like, since we have 2 sides of 2 right triangles. Okay, but I'm going to use the corollaries just so we can practice it. This leg should be the geometric mean. X should be the geometric mean between the side of the hypotenuse closest to it, 4, and the entire hypotenuse, 9. Cross multiply, x squared equals 36. Take the square root, x equals 6. Okay, again, I'll bring to your attention that we have a right triangle, and we know 2 sides. So we could always use Pythagorean's theorem to say, okay, 6 squared plus z squared equals 9 squared. Okay, so you can use Pythagorean's theorem, but I'm not here to teach you Pythagorean's theorem. I want to show you how the corollary works. Okay, and so here we should notice that z is the geometric mean between the side it's closest to and the entire hypotenuse. Set this up. Z is the geometric mean between the side it's closest to 5 and the whole entire hypotenuse, which is 9. So 5 times 9 is 45. Z squared. Take the square root, and I should get 9 times 5, 3 and 3. And so I get 3 radical 5. All right. Last one down here. It says, at the golf course, Maria drove her ball 192 yards straight at the hole. Her brother Gabriel drove his ball 240 yards, but not right at the cup. Find the remaining distances for each person. All right. So at a golf course, drove her ball 192 yards straight at the hole. Seems like she's here. I gotcha. So she here, 192. And he's here at 240. Right? Because they started here. 192 goes there, 240 goes there. Find the remaining distances for each person. Okay, so they want to know Maria, I'm just going to say M here, and Gabriel, G here. They want to know those two. All right, and we are given this. Now, the nice part is we kind of know that we can find either of these out. I can use the corollaries to make this a little bit faster, right? This leg should be the geometric mean between this side and the entire hypotenuse. The entire hypotenuse. Okay, so what I have here, as I'm looking at, is 240. 240 should be the geometric mean between the side closest to it, 192, and the entire hypotenuse, which is kind of tough because I don't know what it is right now. I'm going to say 192 plus m. Okay, but there's still only one variable, so very solvable. These are going to be big numbers though. 240 times 240, 57,600 equals, what's 192 times 192? Have a lot of calculators up. 192 times 192, 36864 plus 192m. Okay, so 5,760 minus 36864. Okay, that's 20,736. So 192m. And I'm going to divide both of those by 192. 108 more yards. So Maria has 108 more yards to go. Okay. Now I need to find Gabriel. And since I already know that this is 108, and I'm glad that that's a nice number, G should also be a geometric mean between the side it's closest to and the entire hypotenuse. Okay, and so what I have here, G is the geometric mean between the side of the hypotenuse it's closest to and the entire hypotenuse, which that comes to be 300. So 300 times 108, 32,400 equals G squared. And I'm going to take the square root of that number. Square root 180. All right. So Gabriel has 180 more yards to go. Okay. So now these are shortcuts using those corollaries will help us to save a little bit of time rather than redrawing and relabeling all of our sides as short, medium, long. And it's kind of helpful, especially if we're struggling to identify what is the short leg and what's the long leg. Okay. So there you have it. Similarity in right triangles using the corollaries, the shortcuts. All right. See ya.